In the previous video, we have seen how atomic mass is measured. Now let's understand atomic mass in detail. Before that, can you tell me what exactly the concept of atomic number is? Can you define it once for me? Yes, it's simply the number of protons present inside the nucleus of an atom. Now on similar lines, can you tell me what atomic mass could be? Yes, it simply means the mass of an atom. But how does it get determined? Imagine we have a bag which is made up of extremely thin material. So thin that it almost does not have any mass of its own. Now we fill this bag with some stuff inside. If this bag is placed on a weighing scale, then can we say that the total mass of the bag will be the sum of the mass of all the objects inside it? Absolutely. Similarly, the mass of an atom can be calculated with the help of the subatomic particles in it. But we know that among all the subatomic particles, electrons have negligible mass. That is, they are considered to be almost weightless. So what are we left with? Yes, we have both protons and neutrons in the nucleus. And these two do have some amount of mass is what we know. Now tell me one thing, which among these two particles should be considered? Shall we consider only the mass of protons or only the neutrons? Or both together? Well, since both have a significant amount of mass, we will consider the mass of both together. Hence, the atomic mass is defined as the total number of protons and neutrons present inside the nucleus of the atom. It is also referred to as the mass number. Let us take a simple example. In case of a simple element like fluorine, we find that there are 9 protons and 10 neutrons in the nucleus. Wait a second. We have always come across cases where the atomic nucleus has an equal number of protons and neutrons. So how is it that the number of neutrons is more? Well, tell me, does the presence of additional neutrons really bother the atom? Does the charge of the atom increase or decrease? Absolutely not. That's because they're neutral. Then why should an extra neutron bother us? So coming back to the atomic mass of fluorine, we have 9 protons and 10 neutrons. That means the total would give us 19. So can we say that the atomic mass of fluorine is 19 units? That's right. Just like fluorine, even aluminium has an extra neutron compared to the number of protons. That is, in a single atom of aluminium, we have 13 protons and 14 neutrons. Summing up the two, we get 27 units, which is the atomic mass of aluminium. Now let's take another random example of chlorine. A chlorine atom has 17 protons and 18 neutrons. That means the atomic mass of chlorine will be 35 units, right? Absolutely. But wait a second. A few chlorine atoms that exist in nature exhibit a different form. Some of them have 17 protons and 20 neutrons. That gives us the atomic mass of chlorine as 37 units. So which one is the correct atomic mass? In case of chlorine, both the atomic masses are right. The atoms having 17 protons and 18 neutrons have an atomic mass as 35 units. On the other hand, chlorine atoms with 17 protons and 20 neutrons have an atomic mass of 37 units. But now the next question to pop up in our minds is, how can we have one element having 2 different kinds of atoms? And is this valid only for chlorine, or are there other elements also which exhibit this phenomenon? Let's find out more about this mysterious concept of isotopes in the next video.